Okay, thank you very much for the introduction and thank you very much for your attendance. Good afternoon, everyone. So as presented, I am José Hernández from CARTIF, and my work will be about the data quality. So very related with the previous presentation about the sensor faults and these kind of things, but also we are talking about machine learning, artificial intelligence, all data-driven services that we have in the world, but we are using data for this. Do we really know the quality of the data that we have for doing this? Is this data biased? Is this data correct? So basically what we have done is to analyze the different data quality that we have in different buildings, in different pilots across Europe. So with this we can extract some conclusions that is the work that I want to present. Just to provide a short background, this is made based on the DG Build project, that's an European project, just to give you some very short contextual information, that this project is in fact trying to solve the problems of the high quality of the data that we have in the pilots, in the buildings, in the different environments, in order to provide high quality services around the world. For that, we have a set of consortium, different partners, so we are one of the institutions within the project, and just to let you know that we have this kind of pilots that you can see at different countries that you can see in the screen. And here I would like to stop a bit, because our approach is basically we have the different buildings. So let me show you here. We have the buildings, we have the pilot use cases, but we should not forget that the users are part of our building. So the users are also providing data. So we should not forget that they are providing also data, and that's why we introduce the co-creation methods to use the data. And the pilot data is not only buildings, it's the surroundings that we have, electric vehicle. We have a lot of information and contextual information in the buildings that we need to collect. To collect this data, we have the data lake that is composed of different repositories, the dynamic data, or in other words, time series data, but also the static data that will enrich our time series. I mentioned before, we have BIM, we have CTGML, we have different contextual data that enrich our data. And last but not least, the external data that can be data spaces, can be climate services, can be other APIs, external APIs that provide data. With this, we are able to provide a layer based on business intelligence to share the information via data marts, and then to only share the relevant data. That means we are reducing the computational load in the network, because we are not populating all the data. We're populating the data that we really need. But this is one of the dimensions. I anticipated the relevance is one of our dimensions in the data quality, but very important to say that here in the data lake is where our data quality approaches are taking place. That's why I explained the concept. And of course, later on, using all the services that are around the buildings, but assuring that the data that we are using is of high quality in this sense. Then why need this kind of data quality? Because as mentioned before, we have sensor faults. This means gaps, errors, inconsistencies of data that we need to solve in order to take better informed decisions. Because if we take data, high quality data, for taking decisions, our decisions will be more accuracy as well. So that's why we need to have this kind of high quality. As I mentioned before, non-biased data-driven services, and increase the reliability of our results. And we should not forget also interoperability, because we have, as I mentioned before, we have the data lake, but we need to combine time series data, external data, and contextual data. So this is very important, and that's why the high quality is important in our project. In this sense, we have 7 different domains. I will not enter in all the details of the domains, but basically we have accuracy, completeness, reliability, consistency, relevance, accessibility, and timeliness. Sorry for the typo, it's timeliness. In this sense, we are aiming to determine, first of all, the quality that we have in our pilots, with the data that we have in our pilots, and later on to create an approach in order to increase this data quality. So the paper is true that at the moment we have in the stage of analyzing the real data quality that we have in the pilots, and the second step will be the improvement of this data quality. And how we are going to do this? So you can see in the slide, but you can see also in the paper the different approaches with more extended information. But basically, combining different approaches, different methodologies in order to improve this quality. But as this is not the focus of the paper, I will forget this part. In our approach, we have different outcomes or different results that we're aiming to achieve. So you can see some numbers, like for instance, the completeness to have more than 90% of the samples already taking place. So usually, and you will see in the results, we have pilots with less than 50% of the data. So how to train a model, how to train a data-driven service with 50% of the data samples. Also in the accuracy, we detected that most of the samples are out of range and creating some kind of outliers of the data. So again, how to train models with these outliers and how to create confidence on the data-driven services with this kind of numbers. So our approach aims to reach this kind of numbers within at the end of the project with the data corrector methods as well. And how is our approach? Our approach is working in different ways. So we are able to collect data, historical data from the pilots in order to check the historical data quality, but also in streaming, in a streaming way. So first of all, we have the user interface, because at the end we should rely on the users. I mentioned just in the beginning of one of my slides that the users are important. The users are the occupants of the buildings and the end users of the buildings, so we need to take them into consideration. And here also the technical part, the technical users, as they are providing the data, and they probably need also to know how to take decisions about how to manage the heating system of a big building, an office building, and they need to know the decisions they are taking if are good enough or not. So with this, we create the data loading processes that we are able to consume any kind of data format, JSON, CSV, real-time data. So we are obtaining all this data from the user and transforming the data and filtering the data according to a standard data model in order to harmonize and to comply with the interoperability aspect that I mentioned at the beginning, in order to calculate some statistic of data, that means the KPIs or the 7 dimensions that I mentioned before. So with this is the first approach, and of course we need some input of the user, again co-creation, so including the users in the loop. And also we have the streaming line that you can see in green. So we are able to also to calculate these KPIs in a different way, because of course we don't have any streaming, we have just one sample of each one of the sensors, or maybe some samples, but not quite a big data set. But the approach is different, but we are also calculating in streaming in real-time steps the data quality that we have in this exact moment, so instantaneously and also historically. So in this sense, we are able to know if our decisions, our models are being trained with good quality data. And just going to the results of this approach. So we have been analyzing different pilots. I know that I didn't enter the details of the pilots because we have 10 pilots and it's quite big, so you can see them in the paper. And you can see in the screen, I don't want to enter in the details of the numbers, but you can see the difference between the accuracy of the data in different pilots. So accuracy meaning for values out of the expected range of values. And I would like to emphasize expected range. One sensor of temperature can measure multiple ranges of values, but what is expected within the indoor temperature is expected between 15, 30 degrees, more or less, let's say. All the samples that are out of this expected range is detected in this accuracy system. And how to analyze these values is basically using, again, co-creation. The facility managers, the experts of the building provide us this expected range, and we are able to calculate the different values that are out of range. And you can see that there are pilots with very, very good values, like the Forum Video Helsinki in Finland. In Romania, we don't have data, so that's why you will see that it's mostly empty in all the cases. And you can see other cases like EDF in France that is almost 40% of the data accurate. So you can imagine if you take decisions based on the 40% of accuracy of data, how your decisions will be at the end, or how accuracy will be your models. So this is the first one of the results. Secondly, about completeness. So you can see that, of course, the completeness usually, because of the sensors, we have different pilots with very, very high level of completeness of data. But you can see one case on Italy that we have less than 30% of the data complete. So how to train a model if we have only less than the 30% of the data, of the data set? So this is a real problem in the context. Next, about reliability, that is the cross correlation between accuracy and completeness. So at the end, you can see that this is the real KPI that is useful for taking decisions. So you can see that at the end, the pilots are not getting high values. So apart from one of the pilots, but this is because it's very mature pilot, that you can see that at the end we have 80% of the reliability. And also consistency, that this means outliers of the data, statistically speaking. Outliers, not outliers of range of values, but statistically speaking. So you can see that also, again, the difference between the different buildings, the different pilots is really high. So we cannot say that we have a very consistency across Europe, or at least we have tried to cover different buildings, different mature buildings, and so on. About relevance, as I mentioned before, we are only using the relevant data. This is not bad to have low values. It's just to know which is the real value of the data. You can see here, for instance, in France, we only need the 20% of the data to create our model. So why to measure the rest? We are creating computational load, so we are able to detect that we need to improve our system of monitoring. And sorry, this is the relevance again. It's not relevance. I don't remember now the other. But again, it's the same conclusion. So we can see that we have different different values of the buildings, and again with different maturity of the pilots. So with this also we create another approach that I would like to present, that is based on blockchain, in order to detect this consistency of data and to validate the data. And this is the proof of existence. So apart from the results that I mentioned before, with this approach we're able also to notarize the data that we have in the building part. So with this we create the hash of the data. We are able to calculate this hash at the beginning, so we have the communication network, and at the end we have the hash again of the data that we have. So in this sense, we can detect as well if we have any error of the data in the communication process, because of course the data could be consistent here, as I showed you before in the consistency KPI, but what happens here? Because maybe we have good data here, but we send the data to the services, even relevant, consistent, complete, and so on. But what happens here? So with the proof of system schema that we created, we are able to determine this consistency of the data in the transmission of the data as well. The process is like this: we read data, we calculate the hash, certify this data, and verify the data with the hash. Is that what I explained before? And here an example of the immutability of the data. We are sure that the data that we read in the field level and the data that we have in the services has not changed. So with this, we have here the example of one of the pilots, in this case the Veolia pilot in Spain, that we notarize the data. This is the hash of the data. Of course, I am not going to enter in the details of the blockchain network, but to assure that the data that we have to calculate the models and the services is accurate, consistent, and so on. And with this, I would like to conclude my presentation, that the main and important conclusion is that we have different maturity levels in the pilots and the buildings, and this is very important. It's not the same building like the UCL building in London that is very new with a lot of digital services, a lot of digital information, that a pilot like the one in Romania that you have seen, and I intentionally add this pilot because they don't have data. So you can see the two different digitalized building and not digitalized building. So this is the current status in Europe. We are collecting useless data, so why to collect everything? Why to digitalize everything? So we're creating needs of computational load, but we don't need all this information. And of course, there is a point that we have, or we detect that we have a lack of awareness in the data quality. We create models, we create services, but we don't know which data or the data that we are using. And of course, to finalize, we have room for improvement, and this is the work I'm doing. And for the next step, we are currently working in a checker, or a corrector that will improve the information based on machine learning, based on different artificial intelligence techniques that will improve the data until the KPIs I mentioned before. And with this, I finalize, I hope in time. Thank you very much for your attention. If you have questions?